Let's try it. One last thing. No. All right. Good enough. It's time to start. Thank you everybody for being here for our first webinar. As you can tell, it's my first time trying this, and I'll figure out how to do the presenter mode for next time. Um, really excited here. I guess this is being recorded, and so thank you all for either listening or being here today. First, I really want to thank the volunteers. This is a completely volunteer effort. This idea would never have any hope of succeeding without the volunteers. I'd also like to extend my deep thanks to the members of the board and the panelists who are attending today. Um, oh, Camila joined. Justin, if you could pump her up. So what you can see on the screen is the agenda for today. I'm going to talk really briefly about the goals. Well, Kelly talk about annotation. Ryan Duggan is going to give a brief highlight of the annotation working group. Sophie Van Gassen is going to talk about bioinformatics, and Leon will give a highlight of the work going on there. Camila is going to talk about what's going on in outreach. Gotse, if he makes it, is going to talk about the SOULCAP board governance. Jessica is going to talk about the grant, external partner engagement. And then the real thing that I'm excited for is Q&A at the end. SOULCAP started is my own idea of I'm a full stack bioinformatician, and I don't have many chances to make an impact, period. And it was important to me that I do something that I think is going to make a difference in the world. And as a full stack bioinformatician, I don't have a lot of hope. But flow cytometry is important, right? It's used everywhere to cure cancer, to develop immunotherapies. And one of the problems that's facing this field is we're using different words to describe the same thing as scientists. And I believe that if we can change that, it's going to accelerate drug discovery. It's going to make results comparable across studies. And that only makes science better. And that gives me a hope that something I do in my life is going to be important. And I thank you all for joining me on that journey. So started the foundation because it's important that this is a global effort, that it's not just me shouting in the wilderness and trying to find other people who want to join me on this journey and have the same goals and the same desires and the same drive because it is a volunteer activity. And so we started the foundation to bring you and everybody else together, and it's a not-for-profit. Members of the board will be talking today to do just that, to standardize. And it sounds so like minuscule, but I really do think it's important. Just standardizing the terminology that scientists use every day to annotate cell populations. And to do that, we're gonna have to work with lots of people. And this is where I got it totally wrong. Coming from my background as a bioinformatician, I thought, it was a bioinformatics problem. But we need reagent vendors. We need all the different software vendors. We need partnerships with clinicians, with scientists, with organizing, notifying bodies and the government. And that's happening. These groups are coming together. They've heard our call. They're excited about this. They're donating reagents. They're donating time. And that's why I can stay here today, that I really, 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 really believe this is going to work. But we have a lot of work in front of us. But it's exciting to talk about what's been happening over the last year. And I'll hand that over to most of our team to be able to talk about that, starting with Kelly.
Great, thank you. Okay, just to give you a quick overview of what the annotation team is doing, our mandate is generally to compile every current recommendation that there is for every essential immunophenotypic combination, including exclusion markers that results in the same downstream populations, that when we call something a Treg, when we call something a naive B cell, when we call it that thing, when we name it, that it is actually all of the same events that exist in that population. So fundamentally, that's like at the core of everything. And that isn't just one combination. That might be one combination that creates a standard or a data standard, for example, but the combinations themselves could be many different things, as long as what's resulting is the same. And then my group is also tasked with kind of creating some empirically validated marker combinations. Some of the data that's going to go downstream provides some recommendations for the gate logic and address any of the concerns. Because, like, as a biologist, you guys know there's a reason why this has been such a difficult task, for anybody to think of taking on, let alone in a volunteer capacity. And that's because things like clone validation, sample prep considerations, there are so many different things that have to be validated that can have an impact on the quality of the assay or the quality of the data. We want to create guidance around the assay performance itself. I don't know exactly what that looks like yet. We're probably a few years away from that. But to start to create some metrics around that, some quantitative metrics. But fundamentally, this is right now what we're doing is building the foundational work that addresses the relevant, all of the relevant factors towards these marker combinations. On the left-hand side, besides me, if you want to talk to anybody else on this list, it's the people that have volunteered to lead the different teams based on different biology groups. I have a lot of members who are active in multiple teams, but these are the team leads if you have any questions besides me. So go to next slide. Okay, so fundamentally what we'd like to do before even the end of the year, who knows if that will be possible since it's only a month away, but is we want to start creating what I'm calling annotation playbooks. And these are, written documentation of the marker combinations, the conditional exceptions, which is what I call the different marker strings that we're relating back to the standard marker string. Anything where, again, you get the same downstream result. The required exclusion markers, the markers that you can't exclude, the things that we routinely do wrong when we're gating, and all the empirical validation. So having a place to put that visually, explain our logic, what our questions were, how we answered those questions, start to compile a working, living document that hopefully will change all the time. And from this document, be able to eventually transfer it online to a more interactive interface where it's going to be easier for SMEs and for people to access this information. But it becomes what I believe to be kind of the playbook. And so the B cell team, the unconventional team, the conventional team, we all have our own playbooks that we're assembling this information into. So I kind of broke it down into these little paragraphs on the side because that's how I see it in my mind. But you have marker concerns, but then you also have gating concerns, your gate logic, things that are very specific to different cell subsets, and we voice those questions and capture those questions and work through them. The biological distribution in humans, I think that we're going to see things like gender differences, ethnicity differences, disease differences. There's just a lot of other factors around, just protein expression in humans. And also the distribution of those cells in particular in each of those kinds of people. And then just kind of an ongoing living list of what's continuing, what additional questions that we have, what is the further work that we need to address, trying to capture those so that when we do have volunteers that are willing to take on special projects, we have a place where they can go to kind of attach themselves to a particular thing. I think you're going to make it go away, Ryan Brinkman.
I won't touch it.
I wouldn't touch it. And then at the very end of it, a lot of the smaller questions that I'm going to talk about, which are things like clone validation, sample prep validation, and then just the massive list of citations that we continue to amass. And so I show on the right-hand side the show your work, because I think that our effort reflects a lot the mentality of an OMIP, which is rather than just make an assumption, rather than just go off of what has always been, why don't we actually show our work as to why we are making and drawing any of these conclusions? If we can find it already in the lit, if we can already find data online, absolutely, we want to pull that and start, asking some of these questions through that data set, or we're going to empirically generate it. Next slide. Okay, so just to give you a really quick, I wasn't going to show any data, but then I got too excited. So just to show you some examples of what some of the questions are that we're asking. These are like my personal pet peeves. So I don't think that we use enough exclusion markers. I think that we think that if something is in a CD3 gate, for example, that it's a T cell. And that's not true. I think we have constantly contaminated populations where we don't exclude enough. And it's one of the challenges that we're finding with data online too, like in the flow repository from OMIPs and things like that, is trying to find data sets where it goes after the B cell subset markers that we want, but it doesn't actually contain enough exclusion markers. And we want to change that. And that might be a slow process. I'm fine with that. That might just be, but what I want to show people is how important it is for that to happen. So in this gate here, even if you have a really tight lymphocyte gate, that is basically meaningless. And you have no idea what you've lost by making a really tight lymphocyte gate. And then even if you go to a singlet gate, like we all typically do, even within there, you're still going to have things that I believe are probably immunologically synapse cells, but we can't biologically say that unless we had some imaging technology along, parallel with this. So say from there that I try to exclude my CD123 from my 3. I think that that should be pure T cells. But if I look at all the things that are contaminating my CD3 positive after having these two tight gates, I still see granulocyte contamination, even though these are frozen PBMCs. DC contamination, they're double positive 11C and HLA-DR. And then in this instance, with HLA-DR and CD11C, activated T cells can be slightly positive for both. So in that instance, that gate has to be a NOT gate from the double positive. These are things that I don't think that we regularly employ. I think that we regularly think that you need to just gate out these things that you think of as canonical markers for these subsets. And we need to not do that. So on the right-hand side, the two plots that you're seeing that are colored, the density plots are the fact, for example, with with T cells, you can't exclude CD56. You have, if you think you're getting to this, to this T cell population, if you gate out CD56, there's going to be a whole bunch of both CD4 positive and CD8 positive, CD56 positive cells. And, at least people are now starting to call those what they should be calling them, which is NKT-like, not NKT cells, but NKT-like cells. But they're very abundant. They're not a minor population in T cells. And then the plot to the right is even after all of that kind of isolation, if I was just going off of my TCR alpha beta population, you can kind of see what that HLA-DR population from activated CD4s are. It's specifically a bacterial contamination, that infection that a lot of the lit is saying is true. So these are things that I really want us to empirically demonstrate. I think it's really important. So next slide. That's an example of one of the things my team is doing. Second is things like clone validation. There's OMIPs are awesome for clone validation, but we need to do it in an even more structured way. So between the HLDA consortium, the HCDM HLDA events where they're actually looking at new clones and comparing them with proteins, we need to attach to that. And then also take what we can find out of the OMIPs. But this is just an example of something that was demonstrated as an issue in OMIP 20, where I went back and empirically validated it and found that I was still struggling to see the VD2 high population being able to be detected with TCR gamma delta. That could be for all sorts of reasons. It could be the conformation of the protein, but it could also just be steric interference. It could be steric hindrance. And so the kinds of things that based on this empirically tested combination that we have to address is kind of the verbiage there on the right, which is an experiment where we have a screening panel. We can, from all of our different vendors, take every single clone of TCR gamma delta and test it for steric hindrance and for conformational changes and differences between donors in a structured, regimented way. So another example of what my team is doing. This was done actually by Fanwa Masaggio from Beckman Coulter. And then finally, my last example is just trying to give recommendations based on what the gating scheme should be. And to me, the best example of this, because I've been doing a bunch of work on unconventional T cells recently, and so it's become kind of a pet concern of mine, is normally we would think that the gate, or how this is typically done to get to conventional T cells right now, is just from CD3 positive after we've dumped all of our markers, and then they go straight into memory markers, they go straight into helper markers. They don't exclude unconventional T cells, which are a massive effector population of T cells. So this would be like my recommended gating scheme, kind of would be going from all of those exclusion markers to CD3 by TCR alpha beta, which I'm using in lieu of gamma delta. So you can only be one or the other from taking the alpha beta. And then excluding the iNKT, excluding the mate cells, and then getting to a 4 by 8 distribution going in, taking out Tregs, and then going into T helper cells. This would be the flow that we would like to see as the recommendation to make sure that when I get to a T helper subset, I've done my best to remove anything that could be contaminating that population. So on the right-hand side, what you're looking at is a question that I've been asking myself, which is, does it matter whether or not iNKT or mate cells are excluded first from that path of analysis? And by actually capturing in the same data set, just analyzing it in a few different ways and seeing how many events I get in the final gate. And there is an impact, but iNKT are so rare in non-obese humans. You have to collect like 2 million events to get a proper iNKT population. And so you're only looking at something that has like 100 events. We also have to determine what's statistically significant. How many events do we have to have in a final plot? Um, and then I don't know the answer to this yet as to which way or which order is going to be, whether or not there's any replicates in those gates, whether one is actually contaminating the other. So these are all some of the questions that we're grappling with. Go to the next slide. And this is how you can be involved with my team. If you are able to generate data, we are in the process of putting together panels that hopefully different vendors will sponsor. So to decrease the cost to any of us, since this is volunteer for all of us and we haven't generated any revenue yet, in order to buy reagents for you, for example. But if you are already using a SciTech panel or you already have an OMIP in process or any of these things, we would love to couple with you in order to take your data, put it into the downstream process, or you could just take ownership of different special projects. This is really great if you are looking for special projects for your RAs in your lab. That they might take on a clone comparison project, and that would be a poster for them at ISAC or something akin to that. But these very manageable, bite-sized, empirical, processes. And or you could take on a different kind of special project, like look into the lit for me for all of the, I mean, T cells are going to be out of control because there's going to be so many different activation, senescence, maturation, and inhibition markers, all of which are meaningful. Do they actually produce a different subset? Is that something that we can actually name and that we should be, creating a naming convention for? You could research different clone validation. You could be our partner with the HCDM, for example, go through all of their previous 12 PDFs worth of clone validation information, assimilate that information for us, and kind of report back to the group, or do the same with OMIPs, for example, or research different conditional exceptions. That's going to be also just an ongoing living document that's going to need to be constantly updated. If people are really good at using AI tools, for example, I just met an individual named Stan who is going to help me a little bit with maybe taking a bunch of papers, extracting out the meaningful information, reporting back, and seeing if we can use that to screen through papers that we trust in order to get information like conditional exception combinations. But also, if you're involved in any of these other organizations, and these are not exhaustive, for example, I think Holden's on the call from HIPC and CDISC. Irene Del Molino was just talking to us about CDISC. But if you can be that liaison between my group so that we can't all participate in everything, but we do need somebody that's willing to communicate with us so we don't replicate effort. We're constantly edifying each other. And then there's a bunch of other things related to our team that I would like people to be involved in. Things like, what do we do with all the data that we get? How do we mine it effectively? How do we manage our data? How do we visualize the data? What is the SME interface to make it easy? And that's something that Antonio Cosma is helping us with. And then what we just started was another group on Slack for population naming. And, to what degree, when you deviate from a marker set, are you still in accordance with SOLDISC standard? That's a complicated naming convention. And then also, we're all doing this as a volunteer. One of the things I'm working on, and as part of my real job, is to start this whole effort in mouse. So that's going to be my focus for next 6 months, is trying to create the different marker combinations. And if you're interested in participating in that as well, I definitely want to hear from you. So contact me on Slack is the best way to stay in touch.
Thank you. Ryan Duggan is going to talk about defining granulocyte populations in whole blood as a worked example of what's going on in the annotation team.
Great, thanks. Yeah, so just briefly, what we set out in the beginning to do here is kind of mine the data that's been available either through OMIP or other published data or expert consultation to say what markers are actually necessary to identify the various granulate subsets in human whole blood, healthy whole blood. Um, Generate this data using a panel. So just make some kind of panel to kind of identify all those populations. I also wanted to run the panel on a few different instruments just to see how it performs, if there's any issues that pop up from there. And then lastly, try and create those definitions for the various granulocyte populations. This eventually the data will be turned over to Bioinformatics group for some automation and whatnot. Next slide, please. Okay, so this is the panel that was used, and we don't have to go through this, but essentially the markers that would be necessary are highlighted in red. And then there's a few other additional markers that I think are useful for both exclusion, like Kelly was just talking about, as well as related populations. And then I did do some kind of a dump gate just for RBCs and platelets, since this was human whole blood. And then other antibodies were present just to identify some related populations like various monocytes and BC subsets. Next slide. What's not included in the panel is also a question that comes up quite frequently. People will many times want to add markers like CD10 or 177 or CD11B, which are all valid antibodies to add to such a panel. But what we're trying to do here is really zone in on what the necessary antibodies are, markers are for these populations. And this gets into a little bit more subsetting than what we want to do. For example, CD10 looking at maturation of neutrophils, which might be more disease relevant than steady state whole blood. Same thing with 177. And then CD11B, I just found it to be pretty redundant in everything else we were looking at. So certainly it could be added in, but maybe not necessary. And then lastly, we were originally looking at mast cells, but due to maybe the abundance in normal whole blood, made it difficult to kind of really focus on that population. So I'm not going to really talk about that much in this data set. Next slide. And then just for the sample, I have access to internal blood donor program. So this is freshly acquired whole blood from healthy donors, from which I stained about 100 microliters with the antibody cocktail with all the blocking and additives in there. And then finally did a lyse fix with the eBio one-step buffer. After that, I did do a follow-on stain of any residual RBCs and platelets to remove them from the analysis. Next slide. And here I'm just showing you the necessary cleanup gates up front that was done. So first, starting on the top left, we're looking at just the CD45, again, versus that platelet or RBC dump gate. So we're gating on the leukocyte population, cleanup for single cells, and then removing TB and NK cells. So the negative gate of T cells, negative gate of CD19, and negative gate of CD56. That should at least enrich dramatically for the granulocyte subsets. In the bottom, I'm just showing you what the 45 and scatter looks like after those TBNKs are removed. So now you can see we just have the nice granulocyte populations and some monocytes that are present. The next slide. And the very first question that many people come to here is this decision between CD15 and CD66B. Traditionally, I find that most people may be working in an academic setting, maybe gravitate a little bit more to CD15, whereas if you're in a clinical setting, maybe you have moved over to 66B. Looking at that center plot, 15 versus 66B, they're essentially correlated. So in reality, either one could be used. I find that 15 just has higher expression. So I feel like I get a little bit better separation and granularity in looking at 15 compared to 66B. So for my definitions, I'm using 15, but again, there's no reason why 66B could not be used in this case. Next slide. And the next thing that I think was fairly critical is, again, Kelly mentioned gating and kind of that order of gating. And so what I wanted to do here is really remove that abundant neutrophil population. So we define neutrophil by the co-expression of 15 and 16. And now if I do a NOT gate of the double positives, that allows me to reveal better the subsets that are defined by CD123 and CD193. So you can see on the far right there, that's a plot that is gated on not neutrophils, and you can see the resolution of those populations is a little bit nicer. So you get a bit more confidence in gating those subsets from there. Next slide. And then from that, we can really identify most of the remaining populations that we're interested in. So that center plot there again is that 193, 123 gated on not the neutrophils and TBNK negative. And then on the top left, we're looking at the eosinophils. So those are 193 positive, 123 negative. I added, in addition to that, some cleanup gates that are in the final plot of eosinophils and basophils. So the basophils then would be 193, 123 double positives. And then people have used the Fc epsilon receptor 1 alpha as kind of an additional defining feature of the basophils. On the bottom half of the 193, 123, we're also able to look at things like PDCs, which are 123 positive, 193 negative. And then the double negative population there would be the rest of the monocytes and dendritic cell populations that would be revealed by, say, 14 and 16, like you see in the bottom. And so the definitions there on the right of eosinophils and basophils would be what we would use to kind of requirement to call these cells eosinophils or basophils. And next slide. However, there's maybe some additional insurance that you might want to add to a panel such as this. I'm thinking specifically the resolution of 193. If you're on an instrument where maybe it wasn't resolved as well or using a poor color, not having good resolution between 193 and 123, let's say in defining the basophils from the PDCs, you might have some additional cleanup needed to really zone in on those populations. I've added another plot there on the far right, looking at CD303 and HLA-DR. The PDCs would be, in addition to 123 positive, they would be CD303 positive, and they would be HLA-DR positive. So those are easy to pick out there. And then you can get a cleaner take on basophils by excluding both 303 and HLA-DR. And that would be a cleaner population of basophils. I've noticed looking amongst different donors that the Fc epsilon receptor has variable expression. In some donors, it's very high. Some donors, it could be low. And so you could easily imagine a situation where just based on Fc epsilon receptor, the basophil and the PDC populations could potentially merge into one. Next slide. So in the end, you can imagine a process such as this to gate the granulocytes starting from the top left all the way down to the bottoms. And I won't go through this, but essentially it's, that 15-16 gate is that first checkpoint. And then the 123, 193 gets you to the rest of the granulocyte populations with some potential cleanup on the far end. So either using HLA-DR or Fc epsilon or 123 and 303 for the PDC. Next slide. And finally, I just wanted to demonstrate here, I was able to run this same or similar panel at least on the 3 different spectral analyzers, so the Aurora, the Opteon, and the Zenith. I did have to change the CD45, if you'll notice there, to a different color because we couldn't resolve those well on the Opteon and the Zenith. So But we get, for the most part, similar um, populations present and similar patterns even. So I don't think that would be an issue. Next slide. And then, yeah, just thanks again to Rasha and Amritesh and Kelly, who helped kind of define the goals here and marker and whatnot. And then, yeah, the example playbook that Connor and the BFEL team have put together is helping me put together mine one of these days. And yeah, I think that's all I have for my slides.
That
There
was
might be
awesome.
others, but yeah, you can skip that. Thanks.
Cool. Next off, I'm really thankful that Sophie Van Gassen is leading the bioinformatics effort and can talk a little bit about what's going on in that group. Thank you so much for being here today, Sophie.
Thanks for
And
the nice
you asked
introduction.
me to check that.
It's fine. I already realized when you were not in presenter view. So
I
lots of
could try and
different
change the
boxes.
presenter view, but
No, no, no. It's
you're
totally
just
fine. I
so
think I
sorry.
think people can handle. So normally text was supposed to be appear in bits and pieces, but that's totally fine.
I'm so sorry.
Um, The overall goal of, I think, this whole project is indeed what already was nicely introduced by Ryan, and the way it translates a bit in my head is that we go towards automated annotation of cytometry data, and by having that automation, indeed also having that aligned among researchers around the world. And in an ideal world, we have all these nice things that were just introduced by Kelly and Ryan, where we get to an agreement on cell type definitions with all the markers defined, with the gating hierarchies defined, where there's lots of complexities and subtleties like they were just explained. But once there's an agreement on all of that, maybe now we can just copy the gates to new data sets, right? In an ideal world. Of course, the world is far from ideal. And in reality, the technical variability and also the flexibility that will always remain present in flow panels just makes that impossible as a goal. I think that we can just copy paste all these gates, even with the more and more standardization we're seeing, and that I hope will stay encouraged and like only get better and better as instruments further develop. I think there will always be some of these challenges remaining. And so what we're trying to tackle in the bioinformatics team is we are trying to think about how to describe these populations in both an interpretable and informative way. And so what I mean with informative there is that just saying, oh, the marker should be very bright is maybe not precise enough to really know what it means in a global sense. Um, Also, how to automate this label transfer from a reference data set to, well, I write here real data. The reference data is, of course, also real data, but like specific data sets of interest that people want to get the labels onto. I think that's really the main question where all the data that's now being generated by Kelly and her team can act as a kind of nice reference data set, which holds a lot of value. But how to then translate that to the data in labs around the world? I think that comes with a lot of potential bioinformatics related questions. And for that, the current work that's being done by the group, and especially I think at this point by Leon, who was so kind to present right after me, is the exploration of some different alignment algorithms. So how can we really get the data aligned to be able to do this data transfer? We're also still exploring different metrics to evaluate the quality of these label transfer methods, because that's also not so straightforward always to have a metric that's really informative for the details we want to see. And finally, we're also exploring this actually at a few different levels, and sometimes it's also easy to get confused there. But you can do this both at really like the gate level, maybe at the cluster level, maybe at the individual cell level. How do you want to apply this label transfer? There's different approaches, and I think there's also lots of value in exploring these different options. the reality of the bioinformatics team is I think that unfortunately, at least speaking for myself, I've not been able to put as much time into the project as I think it deserves, because I think there's really lots of potential added value if we get this set up and working. But I'm very grateful that Leon has been a very enthusiastic volunteer in contributing to this. And so I'm very happy to give the word to him, I think.
Thank you, Sophie. Apologies again for messing up your
No
slide.
worries.
And again, we're all volunteers here, and really happy to show some of the work that Leon has done here on his work, and he spent quite a bit of time thinking about automating label assignment. Um, and okay, you're unmuted. Here we go.
Yeah, thank you so much. Yeah, so continue on what Sophie, was talking about. The problem that we're trying to solve here is that so Kelly will be generating a lot of, reference data set from the SOULCAP. So those data set will be, processed, they will be gated, and they will be, annotated as well. And then we'll also have what Sophie will call the real data from, the community where these are processed and gated data set. And from here, we'll call the query data sets that are, that are not, that don't have annotations or the labels for their populations. So for the example here, what we're trying to answer here is that for the cells that are in the top right population, what label are we going to give it? How are we going to transfer the label from our SOCAP reference to our query dataset? Next slide, please. Yeah, thank you. So the approach that we're trying to sort of formulate and refine here is a 2D, so a bivariate level, a visual alignment algorithm, where we sort of adopt this imitation learning sort of approach where we mimic what a human would do when they are trying to align two things. So imagining that we have two bivariants, and the goal here is what we're trying to do is we're trying to move the query data set on top of the reference so that they can overlap. So as you can sort of imagine, the three components that a human would do when they're trying to do this is they would try to align the color. So as we are showing in the first, so the leftmost plot here, the color here representing the density, right? So this is the one component that we're looking at. The second component is how much the polygons, so the gates, are actually overlapping. And then the third component here is sort of like a fail-proof sort of component, where if the color and then the polygons don't really match on each other, the logical sort of approach for this is to align the center points. So to sort of formulate this, we are trying to obtain a translation, value. So for this algorithm, we're only allowing translation so that you can only move left and right and up and down. So there's no, non-linear deformation happening here. And how we can do this is we can minimize the objective function that captures the three components. So the first one is the density, and the metrics that we have chosen is intersection over union, and this represents the color. And then the second one is the gate, so how much it overlap, and the metric that we chose was dice. And then, it's the polygon. And the third one will be the centroid distance between the different gates, between the reference and the query. After we align it, we can, propagate the labels from the reference to the query data set just by a very simple, a k-nearest neighbor algorithm. Next slide, please. Yeah, and here are all the state-of-the-art sort of algorithms that we have tried. We have explored both, 2D, so the bivariate level, and also ND, so the entire data set, with different sampling methods. So the first two that we have tried they come from coherent point drift. So it is a probabilistic model for two sort of point set registrations. The difference here is that the rigid one, it only allows translations. And then for a non-rigid, it's allowing for a local and non-linear deformation. The third one is a very interesting one. It is actually it is a plugin for ImageJ. It is a 2D image registration based on elastic deformation model. So what we would actually do is we have to convert our bivariant plots into an image, and then it can do the deformation, and then we'll propagate the label from there. The fourth one is just a very simple version of our visual alignment algorithm where we only look at the colors. And then the last one is a CytoVI. It's a very new generated model for ND cytometry data. So it is meant for batch correction. So how we sort of how this can play into our sort of problem is that we can sort of think the difference between the reference and query as a batch effect, and by this model we can sort of correct it so that we align the reference and query so that we can propagate the label from there. Next slide. So here are two working examples from that we sort of applied our algorithm on. So in the first row, the first two columns are the reference and the query. So as you can see clearly that there is a bit of difference in the y direction. So after we apply our algorithm, we can see that the query data are aligned with the reference, so that you can see that the first column and the third column's picture are relatively the same. And then we have this, and then we can obtain, and then after KNN, we can obtain a 97% F1 score. And then for the second example, the reference and query, they are quite similar. And at the end, we can obtain a almost perfect F1 score. So before we actually move on, I just want to know that the F1 micro score that we're showing here is quite inflated because we realized that the example that we have shown here are even without translation, just by applying KNN, the F1 score is already really high. So the F1 score shown here, so basically the F1 score shown here are not representative of how actually our algorithm can perform. Next slide. So yeah, so the previous slide sort of gave it's a good segue to like what we're trying to work on now. So we're currently searching for more diverse data set that we can sort of see the difference between the reference and the query. And then we're also working on fine-tuning the algorithm to make it better. And then for a next step, we want to test the limits for our algorithm where we want to prove how different is too different for our algorithm to perform well. And then we'll also add confidence score for the performance so that we can tell the users how confident we are at the labels that are generated and transfer from the template to the query. Next slide. Yeah, yeah, so I just want to take the time to sort of thank everyone in the bioinformatics team, especially Justin, Sophie, and Ryan for all their contributions, all their help. Yeah, thank you so much.
Thank you. That was really cool. Camila is next.
Yes, I will try to be really fast.
Thank you.
So I'm reaching out to you as I'm actually leading the outreach. So the work of outreach is to gather attention from the crowd to marketing our project and to actually organize certain events if there is anything interesting for us. So what we achieved as SOULCAP this year. So first of all, we made the footprint at Cyto. I think that it was a great event. We had a workshop on bioinformatics led by Giovanna, Sophie, and Justin. Then we had excellent talk, plenary talk done by Ryan, and we also had very cool team up meeting. A lot of people, you see, it was like not enough of chairs. So very, very good event for us. What is great, I don't see the over 300 people at the call right now, but I must tell you that right now our community grew into above 300. So can you go to the next slide, please? So yeah, how to manage such a big crowd. We started with CRM, so the contact management software. So right now, all the information regarding our contacts are on this particular platform. So obviously this will help us communicate with you, assign you to the task, and yeah, manage the project better, I guess. So as you see, this particular invitation to this town hall was done with the use of the Salesforce. Can you go to the next one? So what we also almost done is the new website. So it will have a clear structure. It will allow us to navigate within everything what we do and all about us intuitively. That will allow us to strong community engagement. We'll also have possibility to centralize all the information directly on the website. So if there is anything you want to share, if there is anything you want to learn, it will be there. Yeah, I think that it's modern. I think that it's nice. I don't say that the old one was bad. I'm just saying like this will be a bit better. Last but not least, our team worked on the funding opportunities. Right now, this is handed over to Jessica, and I think that Jessica will talk about that a bit more. But there are different opportunities to gather money to actually execute the tasks that Kelly was talking about and make this project a success. So I want to just say big thank you to my team and to all of you actually, because we are outreach, so we love you all, guys. So the next slide is pinpointing the people that chip in significantly. It's Alice, you, Claire Rogers, Sarah Wojciechowski, Andrea Wang, Gotze, and Ryan. So big thank you. And yeah, if you are interested in joining, helping in marketing of SOULCAP, just reach out to us and we are happy to have you in the team. Thank you so much.
And thank you so much for all. You have no idea how hard she worked to get that email out in the CRM. Huge shout out again to all our volunteers, including Gotse. Who I'm really happy to have him on the board, and he's going to talk a bit about governance and operations.
Thank you, Ryan. I think this town hall was pretty fun until we get into this section, but we have to do it. We have to do it. So this year, we committed to registering SOULCAP Foundation as a 501(c)(3). We did that. We incorporated. We got all the incorporation documents that come with that, the employer identification numbers, and without getting into really all of them, what the important part of this is critical for our infrastructure, like the website, getting access to free technology like the CRM and perhaps the hosting, the emails, and other accounts as part of that non-for-profit standard status that we have. So we did that. We did some bank accounts. We did some online donation campaigns. Setting up for online donation campaigns through online donating tools. That has been done. As part of this commitment, we have to work and finish up some of the core company documents, the bylaws, the code of conduct, IP, initial governance charter, record retention policies, and things like that. Some of these are done, some are still in progress. You'll hear more in the next, I guess, couple of weeks, couple of months. One thing that we like to jump on soon enough is the intellectual property. There's a lot of work that's being done. We like to protect that. We like to protect that from other companies that may limit how we implement these standards. And we stick to the commitment to make these standards compensation free and open. That's the promise, and that's the mission of SOULCAP. We also did some agreements. We are in process of negotiating some of these agreements with partners who, in some cases, we ask them to help us with reagents. In some cases, they are willing to actually generate some data for us. So there's going to be donations or sharing of data, but also reagents. And we need this. Actually, there's a lot of work that Kelly is doing that I think this is, in a way, becoming perhaps a bottleneck. Future looking, SOULCAP certification is the vision. So as we're protecting everything else that we're doing, we're going to protect the name, the logo, and the trademark. And we'll have SOULCAP certification in the future. Again, this is not formulated as to sort of the details of it, but it's there. The logic here is something similar to Linux Fair Trade certification, Creative Commons certification. That's where we aim to reach, and of course keep engaging external organizations who have similar missions like ours. Hopefully start engaging regulators that can help us guide this effort. We think that by doing that, we ensure adoption of these standards. With that, I'm going to stop with the boring part and take the opportunity to thank you for everything that's being done. There's a lot of people, there's a lot of good science that is being put together, and I think this is very transformative for flow cytometry and immunology in general. Thank you.
Thank you, Gotse. And finally, I think I was really excited that we could welcome Jessica to the board this year. She's been engaged from the start through ISAC and through our initial grant, and she's going to talk a little bit about the grant structure and further engagement with our external partners.
Yep. Thanks, Ryan. And I don't have any slides in particular. So, and this will be very brief. We're working now on the submission of a grant to the National Institutes of Health. It's about a $2.2 million, and that's really for people's time and effort. So, if you are interested and would like to be involved, definitely reach out. This is something called a U01. That's just the activity code that the NIH places on a research project that's a cooperative agreement. It's what we call a bioengineering partnership with industry. And our this effort actually fits quite well in this funding opportunity announcement. But there are many places where we could submit grant applications to different types of federal agencies or other foundations. So this is just one, and this is kind of a starting place. The other thing we're doing is we're working on the development of the advisory board for the entire effort. So this would be composed of people that are scientific experts, so they kind of bring the subject matter knowledge that we want, but also people that are basically communication and outreach specialists. So we want to ensure like the board's work and what everything is being done with SOULCAP reaches and resonates into the intended audiences that it should. And so as an example, we're wanting to bring in people that are representing International Clinical Cytometry Society, which is ICCS, or International Union of Immunological Societies, IUIS, ESCA, which is the European Society for Clinical Cell Analysis, FOCUS, Federation of Clinical Immunological Societies, and then CDISC. So, Kelly had mentioned CDISC earlier. And of course, NIST as well, National Institutes of Standards and Technology. So there are key people we're thinking of, and we're in the works right now developing the board, and we want that, to have some good representation, as well as, be strategic about it and not have something too broad. But again, with those purposes in mind. So yeah, so that's what I got.
Thank you. I and again, I want to thank everybody here for presenting. Apologies for not checking that slide stuff, but you guys did a great job. And the most important thing is our volunteers. We have a lot of people here, and really I'm happy to stay on as long as people want to talk. If you have a question, just raise your hand and I'll meet you or put it in the chat. And I can't see all the people. So just drop a thing in the chat, or maybe we can even try to unmute everybody. I'm really looking forward to, while people try and think of something, I'm really, really looking forward to 2025. I think is where we're going to really have come out and show the world what we got. The annotation team is really close. The bioinformatics team is going to have stuff coming to do that. And we have a really, really strong wind behind us. It's tough getting started. And Goatse has a question.
I have a question. You know how I'm.
We didn't rehearse this. What are you going to
No, no,
say?
no, absolutely. Why would no? I'm just using the opportunity. Jessica, what's the timeline for the grant? I'm really interested. We need funds for many different things, and there's
Yeah.
certification will take money, reagents will take money. How soon we can see something coming?
We're trying to be very ambitious, and there is the deadline for this particular funding opportunity that we're looking at right now is actually due at the beginning of next year. So it's actually late January. So I think we can do that. I mean, it's based on the submission of a prior grant application that we want to improve and modify. And shout out to Jonathan Irish and Maddie from Sue and Schutz, who both would like to be involved this time around. We had other subcontractors from a prior submission that we need to gather as well. Some of you probably are here on, attending today. So, and there's some individuals that are, like Kelly, for example, is a really important person to have included because of what she's doing with her data set. So again, yeah, so that's the plan for this particular one, and I'd be interested in hearing from people if they have other suggested types of grant mechanisms we could apply to.
Camila has a huge list, a massive list that you may have seen. So we're stacked. A couple questions. One for Kathy. For pass it on to Goatse. For licensing, what are you thinking? New GLP version 2, 3, or MIT? The biggest question is, what is permissive for business use, and what will remain open for everyone?
I'm not sure for licensing. So if I'm reading the question correctly, licensing will be compensation free and open. Certification, that's different.
Yeah, so I'll just add to that. Anyone can, we're giving it free for any use. We need people to adopt it. We put the standard
Yes.
out there. We want vendors to implement that without any cost. We want to work with them. We're here to help. I want Flojo to have a button that says annotate, and it works, and that there is no cost to anybody to do that, and no impediment. Which is why everything, all the software will be released is open source under the most permissive license that we'll come up with. Does that answer your question? If there's a follow-up, let me know.
Please.
Steve Bate. Oh, Gotse, did you have anything else to add?
No, just said please for any follow-ups. Absolutely.
Yeah, and suggestions on how to approach this the right way for the community is important. But from the intent, it's free and open for any use whatsoever. The standards themselves, very important. Steve Bates has a question. Have you explored using unsupervised machine learning methods in high dimensional data analysis rather than 2D alignment and cluster identification?
I guess that's a question for me. Um, I think it's certainly one of the things we want to explore. On the one hand, unsupervised. I think supervised machine learning algorithms in higher dimensional data could also be of interest. So indeed, Leon has mainly been exploring the 2D alignment approach. You also have some alignment algorithms in one-dimensional or higher dimensional. So there's basically lots of options, and I think it would be super interesting to do more exhaustive comparison of these different approaches. But unfortunately, there the actual effort that goes into that is a bit limited time-wise on what's feasible to do right now. So there are some ideas. We're always happy to hear more ideas. If you have specific approaches in mind, feel free to share. And if you would have any time available to share, I didn't mention it as nicely as Kelly, so I'm glad I still have the opportunity now. If anyone would be willing to help out, to try some things, to test out some ideas that could work for these label transfer approaches, we'd be very happy to join you for the bioinformatics meetings, or to have any separate meeting if that would be preferable.
Yeah. Yeah. Our only, I guess, one concern when we did play a little bit around that is time could be an important concept, especially for some of our vendors. Time and compute costs. We really want to keep those as low as possible. We don't want people waiting a long time to get their results, right, and the vendors having to spend a lot of time to get those annotations. Ken has a
Follow up
question
by
about,
email is appreciated. I just see that in
yeah,
the chat. Please
yeah.
do. Yes.
Ken has a question about the annotations are
Yeah,
validated.
you put it on the questions and answer tab.
Oh,
So we know that functional is everything, right? Like we're not, for example, the worst of which being the T helper subsets. If they're not secreting the cytokine, they're not actually the helper subset. So they can have, and you're always going to see these cell types where they've got this like surface distribution of proteins, but are they actually doing the job? And so we can't replicate functional assays in this effort. So we're going based on what other people have determined to be the functional markers. This has to stay just as a flow cytometry effort we don't have the way. One of the things I would love to do though is eventually someday when we have bandwidth and we've got our feet under us and we're producing, like when we're formalized, I would love to be sorting on the populations that we have, forming partnerships with people that are then adding an entirely different dimension to what we do. I would love to be doing that for everything, including like one of my biggest pet peeves, not pet peeves, but one of my biggest questions is when you exhaust all your markers and you have a set of cells left, what are they? I'd like to be giving those to Illumina or to any of the sequencing companies and have them come back at us with something that we might be able to inform and add just an entirely another layer to what we're doing. So yeah.
Cool. That brings us to time. Thank you so much, everybody.